Hello, everybody. Meteorologist Jim Rinaldi here. I want to show you some differences here in the models and also in the models versus reality. And first of all, let's take a look here at this ridge axis. This is the water vapor loop, and it's valid here. You can see here 1715Z, which is about 1:15 p.m. Eastern Time. And here it's very clear to see where this ridge is. You know, it's out here. There's our ridge, like that. There's a ridge axis right about the Washington, Oregon, Idaho border out here. Now let's take a look at where the models say it's going to be. And here's this is 18Z. You can see, here's this is valid at 18Z today. So this is about 45 minutes after this image was taken, with the ridge axis here in the Washington, Oregon, Idaho border. According to the models, in 45 minutes, it's going to be almost to the Idaho, Montana, Wyoming border. It's out in here. Here's our ridge axis here. So clearly, this is the model is much too fast with this thing here with the ridge. And that's the GFS Canadian showing the same thing. So the models are pushing this east too fast. Based on where the ridge actually is. Here, looking at it there. Now, the second thing I want you to see here is this feature out here. This here, right in here, is this. It's this shortwave in here. And this here is what used to be Ana in the Pacific Ocean. And this is the leftover remnant energy, the ghost, if you will. And now this is it on the Canadian. Now watch what happens as you go ahead in time here. According to the model, this is going to be weakening, okay? But here's the thing. If you look at the at this here, it's actually strengthened the last several frames. If you look at if you have the ability to look at a loop, this thing here, this comma shape here, which you can see in here, kind of like a comma there, a question mark or something, that curlicue has just formed in the past several hours. So this thing is not weakening, it's, if not strengthening, it's at least maintaining its identity. So this is a stronger feature than modeled as well. Now here's the thing I really want to show you here, though. We want to compare runs. Now this is the current 66-hour forecast in the GFS, valid 60 Sunday. And you can see here we have this first piece of energy that's shooting out here, and this piece here, kind of a secondary, the upper level trough up coming through the northern branch as well. Now watch what happens here when we compare it to the old run 78-hour. Okay, first of all, this feature up here in the north is weaker. Okay, this is a weaker feature up here on the old run, and this is a stronger feature out here on the old run. So we'll go back to the new run here. You can see this is much stronger, this northern feature, and this is a weaker feature out here. Now let's go ahead. This is the current 72-hour, and look what happens here. Look what happens on the GFS. You actually get a cutoff low over northeastern Pennsylvania, and this out here is not as strong a feature compared to the 84-hour from the 0Z run. And look, this northern feature is just a weak feature. There's certainly no cutoff. It's much further east, much more progressive. This feature off the coast here is much stronger than it is on the current run. I mean, it's clearly weaker, and this is a clearly stronger feature. Canadian, the same thing. Now, unfortunately, I couldn't do the 66, 78-hour comparison because for whatever reason the 66-hour wasn't available. But we'll do the 72 and 84, and it's not quite as striking, but there are still some very notable differences here between the two. Okay, first of all, on the newer run. Well, let's start with the older run first. We'll do the older run first. And I want you to see here where these heights are. Because sometimes when you look at it, you're not really seeing the differences. Okay, so here's 546. I can't really see the line that well, but it's in there somewhere. 543 is up in here. Okay, watch what happens when we go to the newer run. Look, the 543 line is now all the way down in here. Okay, there's our 543. Up in here. Remember, it was all the way up here before. Here's our 546 line. So this northern feature is stronger and it's digging more. Now, it's not as pronounced, as they said, as it is on the GFS, but certainly you're seeing the differences. And also look at the differences here and in the positions of the other features. Okay, here's the ridge on the Canadian on the old run. It's out here. And here's the ridge on the Canadian on the new run. Go back here. It's further west. Keep in mind that according to reality, it's already too far east. So this could be even further west than this run is showing. This might be back in here instead of out here, which would, you know, affect the features down the road. Like I said, it's all a domino effect. So these are things to be watching as we're going forward, as the models catch on to the strength and the position of these systems in real time and make adjustments to that. You know, we could be seeing these things change, and the idea that you know, there's this feature out here is going to be diving all the way down into South Carolina before it comes back out like this. Yeah, I'm thinking more it's going to be you know, coming down from where it is up here, down across the Virginia, North Carolina border and off the Cape, and then up closer and like that. But we'll see what happens. Yeah, certainly, it's always nice when you have a theory and you see the models actually going to your theory instead of having to go to the models and change your ideas. So, well, but we'll see what happens. And, you know, certainly nothing is over until it's over, and you know, people that claim victory or and you know, or give up before the event is over. I've learned a lesson in that, not to do that. So we'll see. You know, the models could end up being exactly right, but we will see, because we are seeing the models start to reverse direction. So that's it. Hope you enjoyed that. Meteorologist Jim Rinaldi. Have a great day.